Example 3, absolute value equation with an extraneous solution. Okay, remember extraneous means that even though it appears as a root, when you solve, when you actually go to verify, it doesn't work. Okay, all right, so let's take a look at case 1. That's where your argument of your absolute value is greater than or equal to 0. So 2x minus 5 is greater than or equal to 0. And case 2, where our argument, 2x minus 5, is less than 0. Okay, so let's start with case 1. We want to take 2x minus 5 and make it equal to 5 minus 3x. And we want to solve for x. Okay, so I'm going to bring my negative 3x over to the left. It becomes positive 2x plus 3x is 5x. I'm going to bring the negative 5 over to the left. Sorry, to the right. It becomes positive, and 5 plus 5 is 10. Divide both sides by 5. We get that x equals 2. Okay, case 2 means we want to take our argument and make it negative. Okay, this time I'm not going to divide both sides by negative 1 because it doesn't simplify matters. So I'm just going to distribute my negative through 2x minus 5. That's going to give me negative 2x plus 5. Once again, I'm going to solve for x. I'm going to bring my negative 3x over to the left. It becomes positive 3x minus 2x is x. I'm going to bring my positive 5 over to the right. It becomes negative 5 minus 5 is 0. All right, so my two possible solutions are x equals 2 and x equals 0. So let's verify. Remember, always back into original equation. So write out the original equation. That way you won't make any mistakes. We're going to substitute in x equals 2. And simplify the right and the left. Okay, so on the left, 2 times 2 is 4. So we get 4 minus 5. On the right, 5, and then 3 times 2 is 6, so 5 minus 6. All right, the absolute value of 4 minus 5 is negative 1. That's equal to negative 1. And the absolute value of negative 1 is 1, which does not equal negative 1, so the left side does not equal the right side. So x minus 2 we have to reject. Or sorry, x equals 2 we have to reject. Okay, so let's verify where x equals 0 back into original equation. So write that out. Substitute in 0 for x. Simplify inside the radical sign. You have 2 times 0 is 0. 0 minus 5 is negative 5. And on the right we have 5 minus 3 times 0, so 3 times 0 is 0, so 5 minus 0 is 5. Okay, absolute value of negative 5 is 5, and so 5 does equal 5, so the left side equals the right side. Okay, you can also do this on your graphing calculator. Okay, you want to, so if we take a look at our original equation, which is absolute value of 2x minus 5, equals 5 minus 3x, then we are going to make what is on the left-hand side y1. So why don't I just change this to y1? Okay, and everything on the right-hand side as y2. So when you graph that, you can see that y2 only intersects y1 at one point, right? Not 2, not like on our last example. Okay, and when you go to check out what your point of intersection is, you will find that it is at 0 and 5. And remember, we are only concerned with the x coordinate when we're solving. And so you can see that x is equal to 0, so that is your solution. Okay? All right, let's take a look at an example where we have no solution. All right, we're taking a look at something a little more simpler than example number 3. What we want to do to start with is to isolate the absolute value. So that means we want to move the positive 12 over to the right. It becomes negative, and so you are going to get negative 3 on the right, and you will have 3x minus 4 on the left. All right, now remember, we can use inspection when we have something as simplified as this to solve. Okay, you notice we don't have a binomial on the right-hand side of the equation, so we can use inspection to determine whether we have a solution or not. Okay, now remember, absolute values always come out as a positive number, so this side is positive. Notice on the left you have a negative. Okay, there is no way that a positive can equal a negative. Okay, and so we say there is no solution, and we can use this symbol for no solution. All right, that ends this segment.